So this project began a while ago, a couple of months ago, from when I'm posting this video, and I was just kind of looking at some of these chopsticks that I have around. These are my mom's, and I was just kind of wondering. One of them, this one on screen right now, we lost the other other half. Um, but I was kind of wondering if I could make my own. They seem pretty simple. The design is it's not too tricky. They're not round, so I didn't think it was going to need a lathe um, or any other types of heavy machinery. Seemed like I could just make them by hand, but I had no idea where to start. So it's kind of where this project began. Alright, so this was the first set that I made. These blanks were cut a little too small. I cut all the blanks on a bandsaw, so I took a normal rough piece of lumber, cut down a bandsaw. I didn't need to plane it. Normally you would plane lumber um, before using it, but since I'm going to hand plane them, I didn't really need to do that. So these blanks are actually a little small. I'll get into that later. My jig was set up kind of weird. But you can see, yeah, so the one on the right is definitely a lot larger and closer to the size that I was going for. It should be a 1/4 inch by a 1/4 inch on the back end, and then the tip is about 1/8 by 1/8. And that's inches. So yeah, these came out pretty well. I was able to get a taper, which is pretty cool. It's definitely the style I was going for. And then more octagonal in the front. This was the next iteration. I tried to sandwich a bunch of pieces of wood together where I'd glue it and then glue different strips of different types. That's cherry, maple, and walnut, and then back to maple and then ending with cherry. But it didn't work. So the first set were kind of bland, and then when I started to try and add designs, yeah, they didn't work at all. They're falling apart. There's no structure. So these were my plans that I had drawn up, and yeah, I just could not get these to work. I made a lot of them, and they all kept breaking. I have a bag on my desk, which I didn't show in the video, but it's full of this design, which is a shame because they look pretty cool. They're cherry and maple. But yeah, the glue, just the joints weren't right. I think it was just because of how I was trying to glue it together that wasn't working. I did end up finding a solution though, so maybe I'll go back to that at a later date. These next three were covered in shellac, so I took a break from trying to add designs and worked on trying to find a solid finishing material. I was using butcher's block and mineral oil to start, which is commonly used on cutting boards. But it was still kind of rough, and it just didn't have that protective film over it that I wanted to make it really easy to clean sauces off. And they were staining. I was eating some noodles, and soy sauce would just stain it and color it, and that wasn't nice. So I tested three with shellac, and that worked really well. So I went and used shellac for the rest of it. And shellac is a food safe finish, so that was working out for me. And then these are more of the first attempt that I tried to glue together. So they broke. It was hit or miss. I got a couple to work, but ultimately it just was not final product worthy. They look kind of cool though. They're the same walnut in the middle, and then maple and cherry. And I definitely want to use hardwood. Hardwoods are definitely the better type of wood to use for this sort of thing. Interestingly, the wood only ever broke on the walnut, and the walnut wasn't breaking when I was making full sticks out of it, which I'll get into later. But yeah, I think it was just the slivers. So this was the first attempt at metal inlay. This was what I really wanted to do when I started the project. I really wanted to make sticks with metal inlay. I couldn't find a lot of sticks online. Originally, the design was going to be a kerf cut, so the kerf is just the width of the blade, and I was going to use the bandsaw, that's the top cut, and then the bottom middle cut and the bottom cut of that were made with pocket knives and random chisels and stuff. And then I laid the wire in, and then I glued it with Loctite super glue, and I hammered it in, sanded it flush. The result just was not appealing. was not what I was looking for. So those were ultimately failed attempts on all 3 of those. Maybe I'll go back to trying to do copper. I'll buy some copper sheet metal and give that a whirl, but the copper wire just wasn't working out. And the finish looked kind of sloppy, and I just couldn't get it to work properly. It was also really small, so I was hammering it in, and I'd split some of the chopsticks in half, so it just did not function as I'd hoped. But I found a solution. So this was, I don't really know how I came up with this idea. I think someone had recommended to use a dowel, and I was having a hard time seating dowels in. And I might still go back to trying the dowel method later on, but this seemed to work pretty well. So I shaved down the back end into like a point, so I could slide washers onto the back. So that's the 2 walnut ones on the right. Those have washers that I slid onto a point, a tenon that I had carved into the back of it, and then I took another piece of wood and used that as the back and drilled a hole through that could slide on. So I kind of sandwiched it all together, and then I could epoxy it. The reason those fell apart was my epoxy didn't cure correctly, because I didn't know what I was doing there. So I learned a little bit about epoxy. You got to make sure it's mixed properly. And then the other issue with those is I was using a Dremel, and I was trying to grind off the rest of it, and it was heating up, and then it was heating the epoxy up, and the whole thing was turning into a gloppy mess. So that didn't work. Later on, I used some washers that I cut into squares first, and then I sanded flush later. But this was a good proof of concept for using a little dowel or a little tenon that I carved into the back of it. I tried some pointy ones. I tried ones that weren't pointy. It turns out the ones that weren't pointy were definitely the better direction to go for that. So that was it. That was like the best method I could come up with for how to put a metal band around the back of the chopstick. And that leads to the first actual design that worked. So it's a little cracked, as you can see, but it does show the method. The tenon is the pointy part in the back, and then it's got the hole that I drilled in, and it's got a little square brass plate that seats over, and then if that were to be finished, it would be sanded down. Those are a whole bunch of little brass squares that I cut. I pretty much made those by using a belt sander. I would put a whole bunch of them on a screw and held the screw in a pair of clamps, and then I pushed it up against a belt sander to grind away to make it flat and square. That's a much nicer carved end on the walnut one. So I definitely perfected. And I'll go in through, talk about it in the design portion of the video, how I got that. I pretty much filed it down instead of whittled it. I was whittling it with a knife originally, and that wasn't working. So I filed it down with a file, and that was giving me a much cleaner result. More flush on the bottom, more uniform. I could actually gauge the width that I wanted that to be. This was an attempt at resin. I still want to do this actually. I want to do a chopstick where the back of it looks like it's breaking off into midair. So I tried to mess around with some resin, and it's strong, it works well, but it's really sloppy and it's covered in bubbles, and it doesn't look right. So that's for another video, another time. I'll try and get some resin to work, but the metal inlays were really what I was trying to achieve with this. So I made a whole bunch of them, and these will be up for sale. I'll link to an eBay or an Etsy. I'm not really sure I'm going to do that yet, but I'll link to some way for people to buy them. And then I also did some hand-painted ones, which you can see on the left, inspired from the video game Ghost of Tsushima, which has been a lot of fun to play. Been playing that for the last couple of months. But these are walnut and cherry, and I found those 2 woods to be the best. I had some swirly maple or curly maple that I was using, and that just, you couldn't plane that. It was terrible. It was shredding, it was tearing out, it was really hard to work with. So I don't recommend, if you want to do this, to use that type of wood. Walnut's really nice. It planes really nice. Same with the cherry. It's a little bit harder, but it planes really, really smooth. this is covered in shellac, so all these are finished and have a couple layers, about 7 layers of shellac on them. And then I use steel wool to completely polish, sand them down. They're super smooth. They feel great. Yeah, they're really nice. They're a little messy by the band, but that's just because I haven't tweaked the best method to seat that band in there. Some of the finishing process. Alright, so start with a block of wood, ran it through the bandsaw, got my blanks. Those are 3/8 by 3/8 by 9 inches. Did a lot of research. 9 inches seem to be roughly the size that a lot of Japanese chopsticks were modeled. I saw some people saying 8.5 inches, but I have larger hands, so I prefer to just make them all out of 9. And then the 3/8 inch by 3/8 inch was important because that is what the jig was set up to for planing them. Here's a pile of finished planed ones, which I was able to make. I'll show you in just a second on the plane, but yeah, they basically mimic the design that I was going for, where it's 1/4 inch by 1/4 inch, and that tapers into an octagon where every side is 1/8 of an inch roughly. Or has like a total diameter of 1/8 of an inch. So this is the jig. This was designed by Nesbuilt Designs. I'll link him in the description. There was a lot of people. I was doing a lot of research. A lot of people came up with designs for making jigs to hand plane chopsticks. There's one you can buy called the Chopstick Master. It's like $200 or something crazy like that. It's made out of metal, and it's adjustable, it's low profile, it comes with blanks and all sorts of stuff. This was the cheapest option. I have access to a CNC, so I took his design and then I actually redesigned it in SolidWorks, or I was using Fusion 360 actually. And then from there I was able to cut out on the CNC router, and that worked pretty well. There was some issues, but that was mainly with my limited knowledge of how to use the CAM software on Fusion. So yeah, that worked pretty well. The first channel you're seeing me use right now is planing a single piece of wood, one of the blanks. It's 3/8 inch by 3/8 inch by 9 inches, down into something that is a lot more uniform and a lot smoother. It's 1/4 inch by 1/4 inch, and that keeps a solid 1/4 inch by 1/4 inch profile on the back of the chopstick, and the next channel over will let me plane that into having the tapers that bring it down to 1/8 of an inch by 1/8 of an inch. And then the final channel is actually tilted at 45 degrees. So you put the chopstick in a 45-degree tilt, and you're able to run it on just the corners a little bit, and you're able to plane those down even further to have more of a taper and more of an octagonal shape instead of a square shape. Rounds the corners, makes them feel nicer. So yeah, you can see I'm putting this into the second channel, and then it's just the same, just planing with a block plane. This is just a cheap block plane I bought at Home Depot, like $15. You don't have to have a super nice one. You just get a cheap one, some sandpaper and a tile, and sand down the chisel. And there's a lot of videos on YouTube for how to do that. And that's kind of what I found really appealing about this project, was there was not a lot of tools required. You could do it all more or less with hand tools for a pretty cheap cost, which I found intriguing, and left the gate pretty wide open to explore how to kind of do this sort of project. So that was a lot of fun. And I also wanted to make them out of like hand tools. I know you could pretty easily CNC cut these or something, or use a lathe. But I was more interested in seeing how you could do it with a more traditional style, which is what led me to the jig. So yep, the jig is by Nesbuilt Design. I'll definitely leave a tag in the description. So I'm going to speed this footage up. This is just, I'm making both of them, and I'm planing them both down. So as you can see there, I actually got stuck on like a little knot. That's a pretty big key to making these. You want to make sure your blanks are cut, so there's not a lot of knots inside the wood. You'll catch on those, and just not great. And you want to have a really sharp chisel. I could probably sharpen my plane. Again, that is the downside to buying a cheap plane, is that you have to sharpen it rather frequently. But yeah, if it's not sharp, then you're going to get some weird tear out, and I think you can see that's kind of occurring here. That was the biggest issue with the other types of wood that I was using, the maple in particular, and some of the cherry, is that it was tearing out a lot. So it was getting really rough, and really just didn't look right. The walnut, I think it's because the grain is just really open. It just does a really good job planing, so it works quite well for this purpose. And outside of that knot that I ran into, you can see it's forming a nice little dent in there, which isn't great, but there's ways to get rid of that with sandpaper later. That is the biggest issue though with finishing these, is they're very thin, so you don't have a lot of material to sand away and clean up mistakes. So if you make a mistake with the planing section, you might just have to start over with a new blank. That one might be trashed because they're very, very small. So a lot of imperfections are quite noticeable if you don't do them correctly. So yeah, this group was giving me a bit of trouble, but it's not too bad. Alright, so this is the next step for making the metal inlays specifically. After that previous step, you would have had perfectly fine chopsticks, but that wasn't good enough for me. I just really wanted to do the inlays, the metal bands on the back. That was the goal of this whole project. So here's how I figured out how to do that. I cut some extra blanks, and I just did the first channel to bring them down to a uniform 25 by 25, 0.25 by 0.25 inches. And then I built, using some other random scraps of wood and chopsticks, I built a basically a miter box for a little handsaw to just cut a nice flat back end piece. And I have no idea how big that back end piece is. I never measured it. I just kind of found a size that looked good. And actually, what I was working off of was a lot of the walnut pieces, due to the piece of scrap walnut that I was using, were actually less than 9 inches. So I just filled in the gap with the washer and then the extra bit of wood to bring that up to a 9-inch size. So, yep, it's pretty simple. It's a little tight, actually, because when I clamped it, I forgot to put something in there. So it's kind of, when the glue hardened, the clamps were on it, kind of pushing inwards a little bit. So it's a little tighter than it needs to be. But yeah, that's how you make the back part, just from a blank from another chopstick. And it's looking pretty good. So I'll do that. I'll speed up the next clip. I do it again for the second stick. Alright, so this final step was making the tenon on the back. So I marked it with a reference. That's just another chopstick that I had that I liked, and that was giving me how deep I should set this. This was a 3D printed jig modeled after the Nesbitt Designs one, but I figured I could try and wrap it all around a single cube, rectangular prism shape, and 3D print that. It didn't work. The block plane did not like trying to cut into PLA plastic, which, as I'm saying that, I should have just done what I did with the other design, which was put a piece of cardboard and packaging tape over the top of it. Which, by the way, the reason I had that on the other design was because I had planed down so much that it was actually making my blanks a lot smaller. So I had to pad it with something that could be replaced. So I do recommend that you do that. It's pretty easy. You just cut like an old cereal box. It's nice thin cardboard. make your original design less than it should be. Put the extra material on top, tape it down, and that'll give you a surface that you can wreck up without damaging the jig. So yeah, I probably should have done that for this 3D printed one, and that would have solved my issue with the block plane scraping away plastic. The other issue with this was I had attempted to use it to resin fill that other one earlier. I used a hand router, a trim router, and dug a hole into it and just completely forgot that the inside of it was honeycombed, because that's how 3D prints print if you want to save plastic. So that didn't work at all, and I completely wrecked up one of the channels by doing that. So yeah, that 3D printer, it's not great. It didn't work for, like, the wooden jig is definitely the better route to go, but I did find a use for it, and that is filing the tenons onto the back of these, and it worked pretty well. So I just cut a little groove on the back in the jig, and then I was able to use the file to lean up against the edge and line up the line that it's supposed to be, and then file each side to the correct depth, and then rotate the piece and continue that until I have a little square tenon on the back of it. And then it was just a matter of turning the piece a little bit and shaving down the corners to get it a little bit more circular, so that the drill could fit in the back. I forget what drill bit size I was using, but basically I just looked at size 8 washers, size 8 small brass washers, and I found a drill bit that was roughly the same size, the inner diameter of those, and then I would shave these down to roughly the same size as that. Yeah, it was a pretty simple process that was actually more work than it should have been, because I just couldn't get a lot of the earlier designs to file correctly. But I ultimately ended up with a system that worked. That seems to be doing pretty well. So the next step in this process is drilling the hole in the back of those little pieces that go with the handsaw. This is an Unimat SL1000. It's an old jeweler's lathe. I'm not really sure how I came into possession of one of these. My mom inherited from, I think, my great-grandfather. I'm not entirely sure. But it's definitely overkill for drilling holes in the back of these. This is a pretty precise instrument. And not necessary. You can use a normal handsaw. Or even, I think the best thing to use might be, you can buy a Dremel work stand that turns a Dremel into a drill press. And I imagine that might work pretty well. But this essentially is it's a little lathe that you can reorient into a mini drill press. So it worked perfectly for what I was trying to do. But considering it goes for, I think, like $700 on eBay or something like that, I wouldn't recommend buying one of these for making chopsticks. There are other ways to do this. Maybe even just a handsaw might be a good go. I was having an issue with, or a hand drill, I was having an issue with my original drill, corded normal drill, because I couldn't get the hole straight, and that's really important. You need the hole to be really straight so that when it seats on the back, it's not super crooked. It can be a little crooked because it's going to be a little larger than it should be. You are going to have to sand it down, so it's not the end of the world if it's crooked, but it can't be super crooked because you are using pretty precise blanks at this point. They're pretty small parts. So yeah, this was a pretty simple process of just drilling. I just wanted to be careful because it was making the whole table shake and going a little slow. But yeah, and then this is me gauging if the depth is deep enough that I'm not going to poke through the bottom of the part. But yeah, this was the best way I found to do this with the tools that I had on hand, but I'm sure there's other ways of drilling holes into the back of these. And actually, I want to try, this is kind of what I was talking about earlier with those layered pieces. I want to try some where I layer a whole bunch of wood, little small squares, and then I drill holes through all those, and then I can run my dowel or my tenon through all of that. And I think that might be a way of doing some of the sandwiched wood patterns that I was showing off at the beginning that just structurally weren't able to hold together. But if they had some sort of joint that runs through them all, that would work pretty well. But you're working with pretty small. This is only a 1/4 inch by a 1/4 inch. They're very small measurements, so precision is key for a lot of this stuff. Which is why I'm just tapping the dials to set this thing up straight to try and get that as close to the center as possible. Alright, so this is it. All the parts are completed. That is the 2 back pieces, the 2 front pieces, and then the 2 square brass washers. And that's everything. That'll put it all together, throw some epoxy in there, let it sit, cure, harden, and then you've got some chopsticks with metal inlays. And I have not seen this design anywhere else online. I've done a lot of searching. There's a cool company. I think it's pronounced Murano. I'm not entirely sure. But they make like handcrafted Japanese artisan chopsticks. And they seat little tiny circles of metal in the back of their stuff. But even from them, I haven't seen bands. So it's a cool design. It's not one that seems to be super common. But it's one that I really like how it looks. And yeah, it's kind of how it all gets put together. So I think next I'll show some of the epoxy process, and I had to actually build a rig for that. So I'll speed through this and then talk about that. So this is what I had to build for gluing. I didn't have any clamps that were big enough, and the few that I had access to from some friends that were big enough were complete overkill, and just way too big, and there's no reason. These things are small little slivers. So I built some clamp racks, and the idea behind these is just a screw and a nut, and you twist the screw while holding the nut in place as you seat the chopstick. And it is a little tricky, and it's a little annoying when the chopstick has epoxy on the back of it. But yeah, it's pretty simple. You just tighten the screw, hold the nut in place, and that creates enough tension to hold the chopstick against the end. But it works essentially like a screw clamp. So this worked really well, and it was super cheap. I had some cedar boards that just lying around, so I cut some of those up and then used some scrap wood that I glued onto the front and back, and then drilled a whole bunch of holes to run the screws. I actually ran out of whatever size screw and nut I was using, a 1/4 inch. So that's why I have a whole bunch of holes and not any screws. But I built the first one that only set 4, and I was making small sets, and it was a pain because I had like 18 chopsticks lying around on my desk, and I couldn't do anything with it. So I built a longer one. And this is the epoxy, it's just normal Gorilla Glue epoxy. And that's just going to go inside that last piece and the tenon just to hold it all together. So here's kind of how I did that. I'd set up the chopsticks. I'd set up the epoxy. Epoxy's really frustrating to work with if you don't mix it. You got to give it the proper amount of time to mix. This set was 20 seconds. And that's what was messing me up at the very beginning, because I was not mixing it properly. Again, I've never used epoxy before this project, so that was cool to learn about, and it's super useful for some other stuff I want to work on down the line. So yeah, spend a decent amount of time mixing it together, and then I'm just going to put it on I'll speed through that section. I'm just going to put it on the backs of the chopsticks and then align everything properly. That's the trickiest part because it's really sticky. I should probably wear gloves, but it was sticking in the gloves. I don't know. I haven't come up with the best method for aligning it because everything's so tiny and my hands are not tiny. So yeah, it's a little difficult to work with, but I imagine you could build a jig where you could seat all the backs um, like a chemistry, like a pipette rack. You could seat them all in there and then dab epoxy on all of them and then jam the ends of the chopstick into them. I don't know. That might work. But this method's been fine. And I'm off camera. I'm just basically putting my thumb over the back of it, holding the main part of the chopstick with the rest of my hand and pinching down to clamp it all together to really seat it for a couple of seconds before I put it into the screw clamp setup. And then I'm wiping off some of the excess. And that's not entirely necessary. It does help later on down the line. If you have like a wet paper towel next to you, you can wipe down the excess, and then you don't have to worry about sanding that off or filing that off at a later time down the road. All right, so then once they're glued together, you just file down the back of the chopstick, file down the epoxy. Sandpaper works fine. I really want to try, I haven't done it yet, but I want to try this with a belt sander. I think that would make it way faster than trying to hand file it. But as I said earlier, I wanted to try and make a couple with just hand tools entirely. And I know that the drill press is cheating a little bit on that front, but yeah, that was part of the intrigue to this project. So the hand file works fine for that. Here's some sandpaper. 320 is what I was using to just clean it up on the back. And this is actually a set of already finished shellacked ones, so I didn't want to do anything crazy with them and rub the file on them. This is the shellac I was using, just Bullseye. Pick it up at Home Depot. I was just using an old t-shirt and rubbing it on. You want to do really thin layers. Those black ones, I was trying to do some burned wood with some of the bronze or brass dust glued on there. They didn't come out too great. They look okay, but I just dunked those, and it's a lot thicker of a coating. So the thinner coating is definitely better. But yeah, that's all of them. That's how I made chopsticks. I think they came out great. Oh yeah, this is 000 or quadruple zero, super fine grade steel wool. Hit the shellac with this at the very end to polish them up, and they'll be super smooth. Yeah, that was working better than the sandpaper. The sandpaper was better pre-shellac or in between shellac coats, and then this at the very end polished everything up, made it super smooth, and just like a final product. So that's how I went from some of those earlier designs to a final design that looks really good in my opinion, and just works out pretty well. I'd say this project is a success. It was a lot of fun to learn about chopsticks and kind of how they're made. And yeah, I got a couple more designs. I got some hand painted ones. I'd love to hand paint some walnut. In the Ghost of Tsushima game, there's some white flowers that would look really cool on that walnut. I did some hand carving ones. That's what I was just showing. Kind of like a tiki sort of carving. And I think some of those could be interesting to get super detailed. But yeah, that's the project. And I gotta mention, this is my BD1 Lego build. The instructions are available on Rebrickable. This is the Uncharted Lego build I did. Those instructions are also available on Rebrickable. I think it's $20 for both of them, or for each, but they both cost 20. And the Uncharted one, I've got plans to do a second one. I'm very excited about that. So maybe down the line I'll post a video about that. These designs are free. You can find them on the YouTube channel. For the Strider from Horizon, and the Serenity micro build, and a mech that I made. Check that out if you're interested. And I think that concludes this chopstick project. So until next time, it's been fun.